Hi there, Mrs. Vaughn here with a short video to help you with your gas stoichiometry woes. Today we're going to be looking at volume 2 mass problems that are at non-standard conditions. So in a stoichiometry problem, we always have to start with a balanced chemical equation. One has been provided for you here in orange. We're looking at the combustion of acetylene. So if we have a 10-liter tank of acetylene, which is C2H2, and it's at 25 degrees Celsius and 1 atmosphere of pressure, how many moles of carbon dioxide will be produced if all of the acetylene is burned? Unlike our previous examples, if you watched our video at STP, we're at 25 degrees Celsius, which is not standard temperature. So we can't just use dimensional analysis and Avogadro's principle to solve this problem. We're going to have to use our go-to method of writing down what we know, writing down what we want to know, and figuring out an equation we can use to help us get there. So when we write down everything we know, we look at our problem. We have a volume of 10 liters, we have a temperature of 25 degrees Celsius, and we have a pressure of 1 atmosphere. So that's what we know. What we want to know is how many moles of carbon dioxide are going to be produced. Unfortunately, I can't go there from here because that 10 liters, that is for acetylene, not carbon dioxide. So I'm going to have to find out how many moles of acetylene that I have. That's going to be step 1. It's going to be really common in these volume to mass problems to have to do more than one step. So step 1 is going to be to find out how many moles of acetylene I have. Step 2 is going to be using our regular old-fashioned stoichiometry to figure out how many moles of carbon dioxide that is going to produce. So, looking at what we know, we have volume, temperature, and pressure, and we want to know moles. Looking over my chemical equations, I see in my gas laws the ideal gas law, which is PV equals nRT. You might hear it referred to as PIV-NERT. If we have 3 variables, R is a constant, so we can solve for that unknown variable. We just have to make sure that our R value lines up with whatever pressure units that we're looking at. Also keep in mind, my temperature was recorded in degrees Celsius. We will have to convert that to Kelvin in order to make this calculation work. So we take our PIV-NERT equation, we're going to rearrange it because we're solving for moles. So when we rearrange it, we divide both sides by RT, and we're going to use this equation to plug in our numbers. When you're plugging in your numbers, I encourage you to keep track of your labels so that you can cancel them out. Make sure that you set up your equation correctly. I just took them out because of space. But you can see that I took my pressure, my volume, I put those values on top. My R value I looked up, and I put that on the bottom. And then again, I converted my 25 degrees Celsius to Kelvin, plug those numbers into my calculator. I always run my calculation twice, and I get N equals 0.409 moles of acetylene. The good news from here is that this is just a regular stoichiometry problem now. There's nothing big and fancy about it being a gas law. It's just regular stoichiometry. If you're still struggling with how to go from moles of one chemical to moles of another chemical, please check out my other videos about solving stoichiometry problems. I have 2 posted for you. One is going to show you the cross multiplication method, and the other will show you how to use dimensional analysis to solve stoichiometry problems. That's it for this video. I hope it was helpful. This is not your final answer. You still have to go do more stoichiometry, but that's only if you need more help with that. So hope this helped how to get at least started. And if you need further help, please, again, check out those other videos. So thank you so much for watching, and good luck.